All right, properties of parallelograms. First, some vocab. A quadrilateral with both pairs of opposite sides parallel is a parallelogram, and usually you'll see markings that look similar to these. Okay, one arrow on a side, the other arrow on the side, that's parallel, and this side's parallel to that one. Some theorems that we use. The parallelogram opposite side theorem states that if a quadrilateral is a parallelogram, okay, then its opposite sides are congruent. Okay, markings could be as simple as that there. If a parallelogram opposite angles congruent, or theorem. If a parallelogram, if a quadrilateral is a parallelogram, then its opposite, we're dealing with angles now, angles are also congruent. Okay, so could look something like that. Oops, not that. That there. Okay, so utilizing that, what we could do is find values of x and y. Given a parallelogram, we know this is a parallelogram because the opposite sides are marked parallel. We have one arrow on CD and one arrow on FG, and then two arrows on CF and two arrows on DG there. So that means opposite angles and opposite sides are congruent, which if opposite angles are congruent, 70 is congruent to x there. So in this case, x equals 70 degrees. And y minus 7 is equal to 22. Okay, so y minus 7 equals 22. Therefore, y would have to be 29. Okay, so we have 70 degrees for x, 29 for y. All right. Let's go ahead and look at some other theorems here. If a quadrilateral is a parallelogram, oh, go back to that. All right, come on now. Then it's, well, this is a consecutive angles theorem, so then it's consecutive angles. Angles are, well, remember, when we're dealing with parallel lines, same side interior angles were supplementary. So they are supplementary. That means if this is x, this is also x because they're the same. This is y, this is also y because they're the same. That would mean x plus y, or x plus y, no matter which way you put it, would have to add up to 180 degrees. All right, parallelogram diagonals theorem says if a quadrilateral is a parallelogram, then it's diagonals. Well, what happens with its diagonals? Well, if I draw in the diagonals, you'll notice they're not congruent, but it does look like they cut each other in half, and they actually do. They bisect each other. Okay, so that would be congruent to that, that to that, and that to that. So if we were to label some points here, we'll call that M, maybe A, B, C, and D, because we're creative like that. We'll say that AM is congruent to CM, and that BM is congruent to DM. All right, there we go. So using those 5 different things, those consecutive angles theorem, diagonals theorem, definition of parallelogram, parallelogram opposite sides theorem, and opposite angles theorem, those are the 5 ways we can show that parallelograms or quadrilaterals are parallelograms, and they're the 5 ways that we use to help solve using properties of parallelograms. So if I'm finding the value of x here, a 75, I know it's a parallelogram because I have the arrow markings. 75 plus x, they're supplementary angles, so they have to add up to 180, which means x, subtract 75 on each side, is 105 degrees. It also helps us to prove triangles within a parallelogram congruent. Okay, so if I were to look at this proof here, I can do this a couple different ways, but if I have my statements and my reasons, okay, I'm given a parallelogram, so rather than writing out the word parallelogram, I'm going to use this little symbol here. Parallelogram GHJK, and now when I'm given that, I'm given all those properties we just talked about We know that opposite sides are congruent. Okay, so since I'm dealing with this triangle right in here, and this triangle right in here, those are the ones I'm trying to prove or congruent, I might say, well, GH is congruent to JK, no kidding there, because definition, actually not definition, I guess you could use definition, but I'm going to use my actual name of the theorem here. It wouldn't be actual definition, it would be the, let me get to it here, opposite sides theorem, parallelogram opposite sides theorem. So I'm going to abbreviate that. So parallelogram opposite sides theorem. Okay. Well, side, remember I can prove triangles congruent using side, 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 angle, angle, side, angle, side, angle, or hypotenuse leg. Well, I have some sides, so I either need an included angle or I need two more sides. And I look at this, and the first one that comes to my mind right now is saying that, and I'll use a different color here, that GL is congruent to JL, and I know that GL is congruent to JL because, well, that's this theorem right here. Parallelogram diagonals theorem. Diagonals bisect each other. So parallelogram diagonals theorem. And I can also use that for HJ, or HL, excuse me, being congruent to KL. Now I have to write the theorem again, but what I do have now is side here, a side here, and a side here. So I have my triangles congruent now. Triangle GLH is congruent to triangle JLK by side, side, side. All right, all done there. Could also use side angle side here. You could have used alternate interior angles and dealt with that and come up with maybe angle side angle as well. Okay, so a lot of different ways you could approach that. All right, we got two more problems I think for you here. This one here, find the coordinates of the intersection of the diagonals of A, B, C, D. So first you have to actually plot your points A, B, C, D, and they give you the vertices. A16, and oops, that is not B, that is A. Holy moly, see if I can get that erased there. Well, it doesn't want to erase for me, so, oh, there we go. And B76, C62, and what did I do here? That should have been 7, 6, there we go. All right, and D02. Okay, so here is my parallelogram. Now it doesn't say just plot the parallelogram. It says find the coordinates where the intersection of your diagonals are. If you draw in your diagonals, kind of looks like my coordinate is right there. Well, it's hard to tell, but what I do know is diagonals bisect each other. So really what I'm looking for is the midpoint of one of my diagonals. So if I want to, like, say, use the coordinate A16 and C, 6, 2, I could find the midpoint of that, which should be that point right there where they intersect. Whoa. All right, that's pretty cool. There we go. So the midpoint of AC would be, well, we remember your midpoint formula, that's x1 plus x2, or x2 plus x1, doesn't matter the order, divided by 2, and then y2 plus y1 divided by 2. Just so you know, the textbooks, anything you look at is going to put the 2's first, so 2 and then a 1. Okay, so my x coordinates put together, so 1 plus 6 over 2, and then my y coordinates added up, 6 plus 2, and divided by 2. So the average of your x's, the average of your y's really is what you're looking at. So that is 7 over 2 and 8 over 2, also known as 3.5, comma 4. That would be a point of intersection there. Okay, well, let's see if that makes sense. So 3.5 and 4. Well, 1, 2, 3.5 and 4. Hey, that looks like it's right. So our point of intersection, 3.5, 4. And you could double check it by actually finding the midpoint of BD, and it should be the same, right? That would be a nice double check there. All right. Hey, one more. 3 vertices of parallelogram ABCD are 3, 8, -2, -6, and 5, -4. Find the coordinates of D. Well, one of the important things is you connect the dots in the order they're given. So A goes to B. B goes to C, because it's read as A, B, C, and then C would have to connect to D. So the next coordinate has to be somewhere up in this area, in this region. Okay, how do I know that? Because if I'm looking at a parallelogram, that other coordinate is going to have to be up here somewhere. Okay, so what we need to do is figure out how to do it, and there's multiple ways. If I'm given a picture, the way I'm going to do it is use my slope. I know the slope of lines that are parallel has to be the same. So if BC is going to be parallel to AD wherever D is over here, okay, then it has to have the same slope as BC here. So what I'm looking at is 1, 2, 3, 4, 5, 6, 7, and 2. So I rise 2 and run 7, right? And so from A, I could rise 2 and run 7, or run 7, 1, 2, 3, 4, 5, 6, and 7, and rise 2, and it looks like point D is right there. Okay, so we have that same slope. Go ahead and mark it off here. All right. And quite honestly, I think I changed colors and did my slope in green and my other in red, but I'm colorblind and I'm green-red colorblind, so I have no idea. However, I know this is the correct coordinate, okay, because your slopes are the same. So the coordinate of point D, D is at the ordered pair 10, 10. All right, I think that's all I got for you. Yep, good lucky.